Good morning. Good morning from Sydney, and hopefully it's not too late for most of you. But thanks for joining in. And just do a quick introduction. I'm Neil from Medulla, originally from Canada. So if you don't pick up the Australian accent, that's okay. And I'd just like to introduce Medulla ourselves and little bit about myself. Now, I'm by no means a LabVIEW guru, like some people here are, but I certainly have had a lot of experience in LabVIEW, and my journey goes back to about 1999 um, when I started doing, my first R&D systems for fiber optics, and I've carried LabVIEW through a whole career progression. It was used when I was in a project designing a Mars rover. I brought it back to Australia to do a PhD, and it was all the systems I did in that was controlled with LabVIEW control, and then progressively getting to more and more advanced systems. Um, Probably the most challenging was just maybe about 10 years ago, working in autonomous automated systems where we're building alignment rigs, and these are systems that had over 36 degrees of freedom, all simultaneously controlled in order to just move optics in free space. And it was pretty intense. And then from there, I've sort of packed up a lot of my LabVIEW development applications and moved more into manufacturing and manufacturing management in the medical device space and had teams of LabVIEW developers. But really throughout this journey, I've realized how powerful LabVIEW is as a tool, but also some gaps along the way that make using it in real applications sometimes a little bit more challenging. And no more challenging than any other application, but certainly just gaps that exist in the market that connecting systems to business systems can be quite challenging. So in this presentation, I'm not going to get deeply involved in LabVIEW. So there's going to be very little. Actually, I'm not going to dive into any source code. But if you really want to get a deep dive into any of the applications that I'm talking about, log into Kurt Friday's discussion where he's going to talk about open source Viper. It's our dependency injection framework that is sort of underlying everything that we do. We're going to make this open source. Kurt will go into deep detail about that. And within that framework is what we call our Viper test executive. And I think that this is sort of the integral piece that we built that really helps connect manufacturing production lines to sort of higher level systems. So please log into that, and Kurt will go into a little bit more detail. So this talk is going to be mostly about how does test and automation systems fit in with manufacturing environments. And as digitization grows, we're going to show that they're forcing manufacturers to change their mode of operation. And the biggest issue that is being addressed is the burden on traceability. Okay, so just think back, toothbrushes are a good example. Very simple thing. They're pressed, they're mass manufactured. Today, they're completely serialized. They can link down, they can talk to apps. You know, Oral B can go and probably log into half a dozen or half a million toothbrushes around the world and push firmware updates into them. So products are becoming more advanced and manufacturing is becoming more serialized. You'll never see it go back the other way. So traceability and digitization is just an ever evolving evolution, and manufacturers are really struggling to keep on top of things. Just going back through bit of past experience I've had, and I'll go through sort of four general challenges that I've experienced in manufacturing and talking to clients. This is quite common. The first behavior that you'll see in many manufacturing production lines is this test until pass mentality. You'll stick it onto a test, you'll stick a product onto a jig, a bed of nails tester, you'll run it, it'll fail, you'll look at it, say, oh, it only just failed that one a little bit. Let's test it again. There's some variability, and it's constantly testing the product until pass, and at what point do you need that quality gate that goes in there and says it failed once, we have to trust that system. Managing rework is another big issue that is always a challenge. Production lines are generally tooled up to build the latest and greatest product, and resources are fairly scarce, so you don't necessarily have, you know, production lines that you're just sitting and mothballed waiting for maybe a legacy version of that product to come through. But when it does, you have to then rejig that line so that it can deal with a number of different iterations of your product, and that can be quite burdensome on the production line, especially if you're still trying to manage product throughput, but then reverse the whatever source code that you have on a particular number of stations, and managing that can be a real burden. And that's along the lines of traceability. So where has that product gone? Who's touched it? As manufacturing advances, you want to have more and more traceability to know exactly what the genealogy of the product that you've pushed through the line. So how do you have that level of traceability? And then overall, you really want to have a good holistic view of your production data. So every step, every instance that's touched that product, you want to have a really good idea um, of who's tested it, when, where, by what workstation, what was the calibration of all that equipment. Simple things in concept, but really in practice to put those together over an organization can be really challenging. And I think there's two main components that really address these. The first one is the ability to validate and enforce business rules. So have a hierarchy of logic that really prevails, that when a product fails, you don't allow it to get retested unless it goes through a certain checklist, all right? And then that has full traceability. And on the traceability and the production data, you want to post all of your information, not just to a shared drive, a network location where people can go and access it, but you want to put it into something that has some level of intelligence where it really links the data, and that you can then go and recoup that data, visualize it in a very simple way without having to do any programming yourself, right? And that's very important for the business. So just going to switch gears a little bit. So production workflows, if you can imagine a production line that is consists of, in my mind, is about four different workstation types. You've got your general assembly line where there's really little information that's being generated, but you want to track activity of all the people on that production line. Then you have work terminals, which are quite often, just standalone stations, maybe a quality control station where you've got one individual that's engaging with the product and maybe ticking off a few boxes. They've got a clipboard, and they're just tracking that, yeah, they've done a visual inspection on X, Y, Z. And then you have sort of probably where most of us are more experienced in, and these are the semi or fully autonomous workstations, which would be, a bed of nails, circuit board tester, or maybe some more machinery that does some level of alignment. And what you really want to do here is, let that station run, but you want to capture that data. And that data most often goes into some database that's sitting on a shared network drive. But the reality is that very few people go and look at that data, nor is that data used in any sort of constructive way to provide you with information, future information on your product. And then you have just remote systems that are sitting there, environmental monitors, temperature, humidity, such. Perhaps a couple of other stations that are just sitting there, just logging things, not connected to any particular production flow, but just they're logging things to make sure that the environment is within a certain set of specs. If that alarm goes off, you want to have that traceability down to your production line so that, potentially you can either halt production for the period that its sensors are going off, or at least have that traceability. So if you're looking at why product failed, you can link the time and date to those events. So at Medulla, we've created really that whole top layer, that that production workflow management system that really controls each one of those workflow steps along the way. And I'll jump into the platform in a minute and give you an overview of what we've created and how it really links to test systems. But if you can imagine an imaginary production line that has, say, four particular steps. A couple of them might be, manual assembly, where you've got people doing a particular job, or this could be maybe a reflow station that's, or a pick and place machine, sorry, that's doing a couple of events. You've got a QC inspection, you've got a bed of nails tester, and then perhaps just some manual assembly. That whole production line will operate in a series of events that typically are managed quite often with a person with a clipboard and a piece of paper, and that piece of paper then follows the product as it goes through the production line. What Medulla has done is we've built an API that all of these stations can now sort of post their transactions for business rule validation and also for data collection and retrieval at the end of the line, so that you can have a really detailed view of your production records. The most important thing, and this is where the real LabVIEW connection comes in, is the ability for our API endpoints to have a true connection down to the platform where there's real product validation and business rule control. So just in a slight graphic here, as a user, you'll log into the system. You'll scan a barcode. So if you want to do a serial number transaction to say that you're going to test a particular product, you'll scan that. The platform will validate your product. It will base it on a whole bunch of rules that has it passed all the previous prerequisites, tests and steps. Is this current workstation valid in terms of all the equipment that's assigned to this workstation? Has it passed all of its calibration checks? Is the user that's logged into this workstation qualified to do this particular task? So there's a whole set of rules that you can manage at the cloud level, which means you don't have to program them into the workstation themselves. So now you're taking that all of those business rules and taking them from being isolated to each workstation and generalizing them to a much higher level. So it really simplifies the development of your workstations, and you're allowing an alternate platform to go and control your workflows. The second big addition, and Kurt will talk about this in his presentation, is the ability to retrieve specification files. So like blueprints for what that job is all about. And this is where I said version control is very important. So if you scan a barcode, the platform will know what product that particular part is, what version it is, and then what tests were originally assigned to that version. So it will create a blueprint that it'll send back down to the test system to say, now this is your test recipe. These are the sequence events that you need to execute the testing in. These are the acceptance criteria for that version of product. And it means that if you have multiple versions of product coming through the production line, that this will dynamically send down to your test station a dynamic profile with all the acceptance criteria specific to that variant. And that means that when you have products that comes through, either return devices that need to go through for testing, long after that version has been made obsolete, you still have a record of that and the ability to manage that and make sure that it's following the prescribed process from years back. And then the ability then to just post all of the data into a highly recognized or highly, say, a good relationship management system, so that you have relationship between product and data collected, and then that data can then be used for more advanced analytics and future things. So, and the other ability here is the ability to, skipped one. Post transaction was the last one I discussed about, where you post that specification file fully completed with all the information. The ability to get data is the ability to request information from perhaps a previous step that the product's been through. So if you do a particular assessment, you check the voltage off a particular pin at an earlier step, that information is stored. At a later step, you might want to use that as input to a calibration routine or whatnot. So you can specify, what was this particular product's performance at this particular step, and you can draw that down from the system. So I'll keep this session fairly open. If there's any questions, please don't hesitate to drop a message into the board. What I'll do now is just bring up our platform. So this is the landing page of a sort of an administrative user, and every user that logs into this platform will get a custom view depending on their business roles and responsibilities. Um, First thing that we'll show you is this environmental systems, these remote systems that are just constantly posting data into the platform. So we have a temp monitor that's running. You can see I've got two workstations that are set up for this particular product. One of them is active, it's blue. One of them is offline, and that's indicated by the gray dot. Now you'll see that we've got two platforms. I can see what their last post, the posting of their last data, and when that was. So this is the one that's online. This one was last posted a few days ago. And we can just go log in, and this is something that anyone can log into from anywhere and just go and have a look at what's happening on the production line, how all the equipment is going. um, you'll see here that this oven has been running for the last couple of hours. Let's just take a look at the last day. You'll be able to see that it's been posting data periodically for, I'd say, for the last couple hours when I turned it on. And progressively, the temperature has been rising up to an alert level, which it hasn't quite exceeded. But let's now find that device. Just drag this in. So this is just a little temp monitor that we've created. And you can see that it's just posting data ever so often. I think every few seconds, it's then doing a post and pushing this up into the cloud so that we can monitor it. Now, our alert threshold is set here at 80 degrees. So I've just now pushed this product, the sensor beyond the alert level. And what we'll see now in the platform, this should refresh every few minutes. I'll just force that to refresh. What you'll see now is that um, it will be reporting an alert status, and then emails and so on can then start going off to the various people. So here's that same station that's now reporting an over temperature condition. Same thing. We can then push it into an alarm state, which then will have a higher level of escalation of alerts and warnings. We can now control this to what I'll show in a few minutes with a production line. When you try to actually process a product on a particular production line, these alerts and alarms can also gate the ability for you to process those products. A warning can come up and say, you can't process this, the room is too hot. So it's good quality control. If we want to look at just overall production level records, we can see that we've got a workflow here that I'll do a quick demonstration of in a minute. Sorry, the bandwidth is a bit limited, so it's a bit slow, but you can start seeing product that's going through the production line. We're tracking just general manufacturing metrics here. We've got our Pareto chart showing our most prevalent failure codes. We've got a yield chart here that's showing that this part number, it would show multiple lines here if we had more than one part coming through this production line or more than one variant. We've got an incredibly low yield on this one. And then we also can manage, look at, say, throughput, what our overall pass and fail ratios are. So this is just a high level summary of everything that's happening. We can also break it down into steps. So this is a 4-part assembly. Um, I'm looking at what my average transaction time is at each one, and I realize that testing this product is, a massive bottleneck in my production line. So we can then go and address that a little bit later. We can also change views. So we have a lot of flexibility in terms of what information we can provide. Quite often you'll find in production lines, this is done by your test system designer. This is a system that's sitting there at the workstation. It's very complex. It's a lot of work for a company to build their own systems like this, and it's very expensive to go and purchase, your typical off-the-shelf MES system, generally linked into an ERP system. So we built this predominantly for small and medium manufacturers so that they can really set up their assembly line and then take all of their automated and um, workstations that are just potentially, just web forms, and all that information can be posted and collected here so that you have a very good overview of everything that's happening. And then you get your detailed summaries on, parts, how many parts have gone through the line, what the status of your product happens to be. And then you can break it down into jobs and work orders as well. So I'll just give a quick demo and then awesome. Okay, so just having a look at the chat. There's been no questions come through, but feel free to pop in a question if there's anything that you see that you'd like to dive into a little bit. I'll quickly get into just a quick overview here. We'll get into the testing and how test systems interact with the platform. We have general product management. So you've got your parts, just a full part summary, detailed of parts. We've got inventory management, both of product that you manufacture or purchase, raw materials. We have full traceability down to, batches or lots that you onboard, but also if it's serialized, we also have serialized management as well. I'm not going to get into too much detail on the platform and all of its features because this can go on for quite a while. But the main idea here is the connecting the workflows, the actual production line, so that you have a connected workflow and you have that rule management. So we'll look at this particular assembly line that we've put together. It's the one that I showed earlier. It's 4 separate steps. With each step, we have the ability of defining the origin. So this is basically defining where the product is allowed to come from. So it's either coming from the pass bin, so the pass location of the previous step, or you can actually put in other, if you want to allow rework to happen, you can say, well, if it fails at step 3, I'll allow it to then re-enter step 2 for a bit of rework. So you can really control how the product flows through your workflows. Set your qualifications. So what qualification or roles do the operators that interact with the product need to have? This is a great way so that you can stop your production engineers from actually pushing product through. If you have a really strict process and you need your operators to be logged in to do that, this allows you to do that gating, to do that that management. Data collection. So this is where the nitty gritty between creating just a tablet-based web form or a touchscreen web form that replaces a paper clipboard versus setting up an autonomous system. So we have a little data viewer where you can log in, you can create the equivalent of a checklist, where you can add elements. We've broken them down into sort of 3 different types. Attributes are just purely data collection elements that you want to put in there. They can be numeric, they can be Boolean, they can be a timestamp. You just basically, you're just going to capture information from the operator at that line. They can be string based, they can put in their own comments. Otherwise, elements can be test elements, and again, they're of the same type. They can be Boolean or string inputs that have pass and fail assessments. They can be numeric values where you have high and low limits, or you can just have to be within a particular operator, say greater than a particular value. And then all of that, all of the validation of the value to the acceptance criteria is then done at the cloud level. So you're not programming your test systems to have that acceptance criteria built into them or hardwired. That is all managed, governed at a much higher level so that you allow all your stations to be controlled by a central source. So if you had 10 of these tablets on the line where operators are entering information and you want to change that limit ever so slightly, you just log into this portal, you make your adjustment once, and that's automatically deployed and applied to all of the active stations that you have on the go. Um, so there's a lot of flexibility. Oops. So there's a lot of flexibility in these systems. If you want to then connect, say, a more autonomous system like a test executive, so that the test executive communicates directly with the platform, you go and you create an automated data collection page. And this is where you can upload specification files. So these can be, our format here is JSON, but these can be equivalent to be XML files or text files that you post into the platform that then on demand are sent down to your test system um, based on a set of rules. So in this example, we've got 4 different specification files, all um, stored in the platform. This version 6 one is what we call the current state. Version 7 might be actually in development, so it's being, we're trying to create a new test system on the line, and and the engineers are testing it on demand. But general production is running the current version, and that test system will request just the most up to date. And so this is the one that will be sent. If a variant product comes through and it requires a specific version, that test system can actually specify that I want this particular version of the spec, and that will be passed down on demand. And let's just go and show that in action. There's a few other things that we can do with this, and particularly around quality control. If you're a manufacturer of product that goes into regulated markets, you'll probably be familiar with, NCR management. And so this is where we allow when the production process doesn't go exactly according to plan, you really need to have a quality management system in place that tracks and traces that product, especially if you want to put it back into production and sell it. And that NCR management system is really important. So we've got that built in that you can, if a product fails on it for a particular failure code, it can trigger a specific type of NCR that allows you to do a very explicit and very restricted amount of steps. And so it's very highly controlled in that regard. And if anyone ever wants to have any more information on that, feel free to come and give me a call. We can set up a demonstration. So I'll just pull up a quick example of that. So I showed you that we had a four-step production workflow. I'm just going to log into that very first step, and what I'll come up with is just basically a live version of one of those web forms that I showed you. So this is now asking me as an operator to enter in a particular component that we're going to consume. And so it's a serialized component, and it's asking me for the serial number of that product. Now, if I put in, let's say, a serial number that's already been used, it will actually go and do a validation check on that and say, no, you're not allowed to use that one. It's already been consumed, but I'll take the next one in stock. It's taken that, it's now linked that serial number to this build. So we have full traceability now on that component. Is that job done? Yes, we can submit it. And now that transaction's been created, all that information has been put into the platform and it's ready to move into the next step. If I tried to process that same device again, it will reject and say that you've already processed this particular one. So I'll move into step 2, which is just a quality inspection step. And those user logins can be password and username password based. They can be RFID, which is in the case that I'm doing here, or they can be, any other biometric device that you have that pulls a serial number from the user. We can set those up. So if I put the product through to step 2, it's going to be a quality control, and I'm going to do a visual inspection and say that passes, and I'm going to make sure that all the, say, risky components have been accounted for, that, yeah, they're all present. I've put this in here so I know what the value to expect. But let's say if I put in the wrong value, it's told me here that this is now going to fail when I submit it. Let's just go back and make that adjustment, and that, yeah, that's passed. I'll submit that. Now the product's been posted. I can log back into the platform and see the progress that's been made. Okay, so that was step 1, step 2. This is actually step 4. So I haven't done step 3 yet. And again, it's just like, oops, that's my login. I need my RFID card. There we go. And so if I've skipped a step, it will tell me this device is not ready for that step. Okay, and then it'll kick me out and ask for me to enter a new barcode. So that was step 4 of the process. I haven't done step 3. Now I don't have a web form for step 3, and that's because it's actually our test system. So this is a snapshot of our Viper test executive. Again, Kurt will be going into detail on this. This is built on the Viper dependency injection framework, which he'll be going into much more detail on. And this is the test executive sequencer test recipe management that will be providing actually open source to the community. So definitely a presentation that I would recommend jumping into, especially if you are interested in an off-the-shelf test executive, so you don't have to go and make your own. So this will log me into the platform. And so this is connected to the platform. It's done a validation. Now imagine that we've now loaded this circuit board perhaps into a bed of nails. We want to initiate the test. I'll scan the barcode of that device. Again, if I scan the wrong barcode, it would just reject it and say that's not valid. But now what it's done is it's actually gone to the platform. It's actually queried the platform, and it's been returned down the most relevant specification file. And it's running through all the tests, and it will come out with an outcome. Now, the specification file that's passed down does contain the program's acceptance criteria that is managed at the cloud level. The Viper test executive that we'll be developing, or that will be deploying, um, you can run it in a couple of different modes. We're running it in engineering mode right now, where I can actually see the high and low limits that are going to be compared, so that I just have that visibility. We also have a production run mode where these are actually hidden from the operator. And that goes back to the mentality earlier, or the frustration, where you sometimes get this test until pass concept. By exposing how close it was to the boundary and knowing that some of these values might have some fluctuation, if I was to just test that again, it's quite likely that um, it might pass. So if you have three fails and one pass, does that make your product good? And these are some of the checks and balances that we're really trying to make sure that that businesses follow really good standard business process. Now, if I was to try and do that device again, it would then reject me. So if this had passed or failed, I could not do it again without having gone through a traceable rework process that requires particular sign-offs by individuals. So this is, I think, for this community, this is a really powerful tool that we hope will get a lot of traction over the next few years, to be able to deploy and be able to do this level of management on the production level. So then I can go back to that fourth step that was preventing me from processing that device. And then here it'll come up, and it'll just be basically bringing it into the warehouse. I can either pass or fail it here, saying no, it's been damaged or it's good to go. I can submit that. And then if we go into our production record summary, eventually, you'll see that if you're keeping tabs on pass count that we had before, you'll see that that should now be one higher. And while the wheels are turning, hopefully, I think it's 9:30 here in Sydney, so I think half the neighborhood is probably just logged in. Anyway, there we go. So that's the Pareto chart. You'll notice that previously we had 7 passes. Now this product has gone through uh, as the 8th completed product. And you'll see that each one of these workflow steps has increased their pass count by 1. Um, and the test time, even though it isn't 25 minutes, in previous examples I've done, I've actually had a very long delay. So that's averaged it out. But everything is there. And production line managers and anyone that's working remotely can always just log in and just view these dashboards. We're also building dashboards that you can customize. So any particular one of those data entry points, if you want to take a more detailed look at the information that you've just collected from the production line, you can take a slightly deeper dive into every single transaction that's been made, every test result that's been posted, um, and get a really good higher level overview of what's been happening. And while that's loading, oh, there we go. Um, so you can take a look at your part summary, all the test data that you've accumulated, and we separate the test data, which is where your pass fail criteria or your pass fail acceptance criteria are determine whether or not the product is allowed to continue moving forward. We separate that from attribute data, which is just general information that you want to collect about particular points of your subassembly or your assembly. Components that are used um, in the assembly. So if you have any traceability requirements on those components, such as those FPGAs that we consumed, you can have a look at all the serial numbers that were used. Um, it doesn't show actually in this view which product that they were linked to, but that's something that we can add in quite easily. If you actually go into that FPGA in its inventory and look at its serial number, you'll see exactly what product it's been linked to. So you have all that level of traceability. Um, Test data is all there. You can go and have a look at all the results that you've collected, take a look at the chart over time. All the information is is there. So on this day, we've had a number of, say, failed devices, and then generally we've passed all those. Files that you might want to link to a particular thing, images, if you're doing, if you have a visual inspection station that's taking pictures or videos of the product, those can all get posted and associated to the test record. And then you can take a look at, detailed transaction history of every transaction that was made on this workflow, by who and when, and take a look at the results. So it's a really detailed dive and tracking, but most importantly, it's sort of the elevation of all those business rules that we often hardwire into individual workstations, and we bring them up to the cloud to make it more generic, and that we can then deploy it and manage it from a much more centralized location. So we think that that's sort of certainly one of the biggest enhancements that this platform provides over other systems. And then just out of due process, we've got asset management, which is your test equipment, how it's connected to maybe higher level assemblies, and how that then forms into workstations as a whole. Eventually this will load. With the equipment, then we have, you can set your calibration schedules, and then whether or not, where is this going? I think I've hit a wall in my bandwidth here that it's really slowed things down, so my apologies. Hopefully the sound and audio are still coming through. Sorry, the sound and video are still coming through fairly clear. There we go. Anyway, so you can have a look at your equipment, how many assets, how many instances of that asset. We also do assets ID management, so that you can give any equipment that you onboard has all your asset management information, and we make sure that that's maintained and unique. Equipment can be put up into a high level build, so that would be, just taking a bunch of pieces of equipment, putting them together, and then a workstation is basically the total system that you want to have traceability about, equipment that's assembled. Some of it can be electronic equipment, or it can just be, if you have a serial number for a desk, you can have that traceability to the workstation. All of that then gets tagged to your production runs, so you have a history of all the components that went into testing and managing a product. User management is fairly generic, and you can assign new users, assign them any qualifications or roles, so that they have administrative rights. Quality management, this is the NCR level management that we've developed. Analytics is yet to come, but this will be a deeper dive into all of that test data that's been accumulated, and trying to find logical and systematic links between products. So think along the lines of like predictive maintenance, but think about it more along the lines of predictive performance, to say, can you identify product that's likely to fail in the future, even though it's passing its particular states right now. But when you start looking at the combination and the history of existing failed components, you'll be able to then draw those, those linkages to help save and isolate products, so you don't invest more money into that product going forward, and pull it off the line and look at it maybe a little bit closer, but to identify those units that are high, that have a high probability of becoming an expensive faulty product. And then now we're also working on sort of our integration, so building in other third party components into the platform. So we have, if you're familiar with the Zero accounting system, we've got connections to Zero. So as you create work orders, those get put into the system and you're all set up to go. We're also working with an equivalent one, MYOB. QAD is a quality management system, and we'll be adding more integrations with quality management, which is mostly around document control, but very important for regulated markets. And then we'll be building other sort of help desk integrations such as Zoom or other, say, Microsoft Teams, where operators on the production line will be able to then, request help from an engineer, and that engineer can be anywhere in the world so that they'll have that visibility. So hopefully that's a good overview of things. I think I've hit my 45-minute mark on this. So I'm just going to now open this up to, I guess, a Q&A session. Um, Anyone have a question, just please just drop it into the chat area, and I'd be happy to answer those questions. Oops. Okay. Um, all right. So no questions have come through at the moment, but listen, if anyone has any questions, you can message me anytime. If you'd like a demonstration or something a little bit more focused on an application that might be of interest to you, please, by all means, um, connect with us, and we'll be able to uh, set up a time and go through that. And again, just remember, log into Kurt Friday's Viper demonstration a little bit later on today, and he'll go through that dependency injection framework that we're making open source, um, and that includes that full test executive. Okay. Well, I'm going to stay online now for the next little while. I'm just going to turn my video off. But if anyone has any questions, just pop it into the chat, or feel free to set up and schedule a meeting with me. But it's been my pleasure, and greetings from Australia. We'll talk to you hopefully again soon. Have a good day, everyone.